Yeah, first of all, welcome to this 400G and beyond pluggable optics module test solutions webinar. So as what Crystal has mentioned, I'm Lawrence. So today I'll be the main presenter to discuss about this topic, right, with you. So before we start the discussion, first here is the overview of the current transport network, I would say. And besides the wireless portion, right, a majority part of the transport network is actually made up of optical fiber, right? As you can see as of today, be it the mobile front haul, the mid haul, the back haul, the metro, and the core network, and also the data center. Nowadays, it's all running with fiber, okay? So that we have able to take the advantage of having the speed, latency, and also the throughput that we're able to achieve using the fiber optics. So in order for us to transmit over the fiber, right, we need to have an optical signal. And one of the key components that we have or that we need in all this part of the transport network is the optical transceiver. And this is what we are going to discuss today, all right? So the agenda for today will include what we have briefly discussed just now, the telecom or the transport network trend that we have today, right? And also next, of course, we are going to talk a little bit more about the optical transceiver trend that we have today, and also what are the testing needs, right, that we are looking at, right, for today's optical transceivers. Followed by, of course, we will also introduce the test solutions that we have, right, on the optical transceivers. And final but not least, about the overall product portfolio of our product line, and then followed by the question and answer session before we close today's event. Okay, let's discuss about the telecommunication trend that we are looking at today. Now, in the past years, as we see, right, the global IP traffic is actually increasing year by year. A very good reason because of 5G mobile traffic, and also nowadays everybody talk about live streaming, video streaming, and also internet TV and so on. And the latest trend, AR, VR, teleconferencing and things like that. All this actually driven up the bandwidth requirement, all right? So with that, right, the backbone is also need to evolve or need to change to actually cater for all these bandwidth requirement or the bandwidth increment needs. So in order to strengthen to cater all this bandwidth requirement, especially the data centers, right, we need to also upgrade the bandwidth requirement as well from the traditional 10G, 100G to 200G and also 400G. And very soon, 800G is on our way as well, all right? So besides the global IP traffic increase, as we can also see, right, the number of internet user and also the number of the different type of device is also increasing on a year-by-year basis. Okay, so this is just a brief overview of what is the current market trend. So when we talk about network service provider, we can actually split into two different types. One we call it CSP, and the other one is ICP. So CSP, communication service provider, there's a company that actually responsible to building the network, providing the bandwidth and so on for the customers. So basically they are fixed network and they are also mobile network or even submarine network as well. Okay, so all these are classified under the CSP. ICP, internet content provider. This I think is quite straightforward with the ICP term, for example, like Amazon, Google, Facebook, Microsoft. All these are considered internet content providers where they have their own data centers and they provide content, right, to their customers. And their data centers actually all over the world, right, to deliver their contents, right, to their customers. Okay. So in the past years, right, there are a few cases or a few scenarios where the capacity of the optical network is keep on increasing. Right? For example, one of the key events that we have is the mobile front haul enhancement. When we move on to 5G, right, the mobile front haul is actually also evolving as well. So this drives a demand to have higher bandwidth on the mobile front haul side, increasing from, for example, in the past, 2G, which is 2 meg, then we slowly move on to 1 gig, and now 10 gig and 25G, right, in the mobile front haul. So all this is being driven by bandwidth requirement from the consumer end. And on the network, we have the PON, right? Currently, we have 1G PON, and also in future, we are also moving towards 10G PON as well. Yeah. And to cater for all those needs, the data center itself also need to evolve, right? So the bandwidth of the data center will increase from 10G, 100G, and so on. Okay, and of course, for that, and also the private network and also the public cloud services, all this will also need to evolve as well to cater for all those requirements. Yeah. So due to that, all this bandwidth increments, the transmission bit rate is also increasing. Okay. So in order to cater all this bit rates increase, besides the increasing in the clock speed for the data rate, some other changes in modulation technology is also needed in order to cater for higher bandwidth. Right, one of example is the traditional modulation, which is NRZ in the digital environment, will be moved on to, for example, PAM4. Okay, so later in the slides, there will be more information or about this PAM4 evolvement, and also how we can actually measure the PAM4 signals. Come back to the data center, right? Let's take a look at the data center evolvement. All right. So in the past, as we can see, data center is actually running on a very low bit rate, like 10 gig, right, and so on. And actually, as we know, as I mentioned, CSP and ICP, they are actually both service providers that provide different part of services on the network system. And very much they are actually working together and hand in hand, right? And also invest on the bandwidth expansion as well, because they need each other, right, to support their expansion. So for example, they want to let's say, for example, ICP, they need to increase their service, like including more throughput, provide higher resolution content, and so on. So in other hand, they will also need higher bandwidth, and the CSP will able to provide that as a higher bandwidth for the ICP, right? So these two network providers actually works hand in hand, and to provide better or fast customer service, right, to their customers. So as we can see, for the trends today, we are actually moving towards 100G or even 400G as well. Yeah. So for the transceivers that we are looking at today, most of the time we are actually looking at 100 gig and above, right? So as of now, as we can see, the deployment of 100 gig and also a 400 gig is actually keep on increasing on a year-by-year basis. Okay. So of course itself on the data center, there is also changes or evolvement in the bit rate increment as well. So on the next slide over here that you can see is much more clearer picture, right? Here is the various layers in the data centers. Basically, they classify as a spine, leaf, TOR, and also the server, which is the lower layer. Okay, so on the highest layer, which is the spine layer, usually we are now looking at 400G with ZR, right, which allow you to do longer distance communication, right, over a longer distance of the fiber, up to 80 or even 100 kilometers, right? Within the data center itself, okay, so with the leaf, the TOR itself, the bit rate is also evolving, okay? So from the traditional 100 gig, you move to 200 or even 400 gig as well, yeah. Why are we moving towards all this higher bit rates, right? One of the key reasons, of course, is driven by requirement for the internet or for the 5G, and so on. Yeah. In today's 400G modules, right, is getting smaller and also lower power consumption. So it's much more reduced in cost and able to deploy in high density as well. So the benefit of this, of course, is allow us to achieve higher capacity bandwidth and also following common standards, right? So towards the open network as well, yeah. But of course, when you want to follow a common standard, how we ensure network interoperability and also able to work between various vendors of Pluggable. So this will be a challenge. And also there's also a reason why we need to test the optical transceivers, right? To make sure that those transceiver that you deploy or that you use in the network is actually interoperable, right? Okay. Another trend is breakout cables in the data centers. Okay, so this is one of common trend, right? So nowadays the 400G breakout cable is actually supported. So with one 400G port, we are able to break out to 200G or 4 times 100G. Right. The key objective behind is to increase density or increase throughput. All right. Benefit, of course, is to reduce costs, and also it's pretty easy for you to replace from 100 gig to 400 gig on the same capacity or on the same port, because the form factor between the 100 gig transceiver and a 400 gig transceiver is basically the same, right? With the same space, now we can have up to 400G. Yeah. Next, mobile edge or so-called edge computing, right? With the involvement of 5G, nowadays we are actually talking about low latency and also low reliability, high reliability on the access or in the cloud service. So because of this requirement of 5G, like URLLC and also MMTC and so on, right? You need to move the data center much more closer to your customers, all right? So that also gives a different involvement on the data centers compared to in the past. The data center can be very far away at the back, at the backbone, and so on. But nowadays, we have to move the data center much more closer to the customer and call this MEC or mobile edge computing service. So with that, the data center nowadays, instead of a centralized in a location, it has become decentralized, right? So to move it much more closer to the customers. And due to this decentralization, connections between the data center, you need to be interconnect, right, as a star topology instead of just centralized topology like this. Okay. And the interconnect between the data centers nowadays, it can be as far as 80 to 100 kilometers away, all right? So traditionally, what we use to connect between the data center is using NUX, or we call it ROADM, and also a WDM network, right? Connect between data centers to data centers. But nowadays, with the 400G ZR coherent transceiver technology, we are able to connect directly, right, without the WDM network. Okay, so this will help the data center operators to save some costs, and at the same time, it's also able to increase their bandwidth right, by multiplexing various ZR transceivers together in a WDM network on top of the coherent transmission, right? So this will further increase the bandwidth of a single fiber that is connecting between data centers to data centers. Okay, so this is the major changes in the telecom network that is coming right towards the future involvement in the data center and also telecom network as well. Yeah. So with that, let me post the first poll right onto the audience, and let's get some opinion from your side regarding the optical transceiver trend. So I think now the poll is available on the screen. Yeah, so please help to participate on the poll, and we will close it in about 1 minute's time. Okay, I think yeah, we can close the poll and show some results. Okay, you can see the majority of you is still working on 100G, and yeah, as what we can see, 400G or 200G or more is actually on the coming, and also some is working on 800G as well. Yeah. Okay, let's move on to the next topic. Okay, so in the next topic of our agenda, we are talk a little bit more about the optical transceivers trend, right, and also the testing requirements of the optical transceivers. Okay, so as I mentioned just now, traditionally we are using NRZ to modulate the signals 1 and 0, right, which is very straightforward. High level is 1, the low level is 0, right, very straightforward. But with the involve of the higher bit rate or higher throughput requirements, right, we no longer able to satisfy the bandwidth or throughput with just a simple NRZ modulation. That we need to increase the throughput, right, per clock rate. So this is where PAM4 comes in. Okay, so PAM4 is able to encode 2 bits on every clock cycle instead of 1 bit on the NRZ. So this will help to double the actual throughput or the actual transmission capacity, right? So PAM4 is able to increase the data transfer, but at the same time, the signal to noise ratio will become worse because it has 4 levels, and each level is much more smaller compared to NRZ. So this is another challenge that we need to face, right, when we increase the throughput using PAM4. But on the other hand, we need to also take care of the signal to noise ratio issue during the transmission. So how we actually qualify or measure a PAM4 signal? Okay, so we use a method called TDECQ. Right, TDECQ just stands for transmission, dispersion, eye, closure, quaternary. Quaternary means 4 levels, right? Because a PAM4 eye actually has 4 levels. okay, and total there is 3 eye. So this is the way to evaluate the waveform quality, right, of the PAM4 signal. And this TDECQ values or the waveform quality is actually directly related to the bit error rate performance, right? Directly related to the bit error rate performance of the signal. Okay, so that's the reason why we need to measure this TDECQ numbers. But of course, besides TDECQ, we're also looking at other things. For example, average power, the extinction ratio, and also the OMA and linearity as well. Okay. Yeah. Well, in order to measure the PAM4 signal, we will actually need to pass through a reference receiver filter. Okay. So this reference receiver filter will be able to filter the noise, right, on the signal. And in turn, you're able to open the eye. And with that, we are able to measure the TDECQ values. So we are actually measuring the eye opening portion, right, to look at the TDECQ numbers using the histogram. So this is a comparison between the traditional NRZ signals that you see on top over here. So in the traditional NRZ signal, we are actually using the mask margin test method. So we check the eye opening on the mask margins, and then we measure how many percent exceeding the mask margin and so on. Okay. On the next slide, I'll give you a comparison, okay, between the mask margin measurement and also TDECQ measurements. Okay. So on the traditional NRZ, which everybody is very familiar with, okay, so talking about average power, extinction ratio, OMA, crossing, jitter, rise time, fall time, and then mask margin. Okay. On the other hand, on the PAM4 measurement, we also do average power. We also do extinction ratio, but we look at the outer ER, which is from the top, from the top to the bottom, and also the outer OMA as well. Linearity. Instead of rise time, fall time, we look at the transition time. And finally, instead of mask margin, we look at the TDECQ numbers. Okay, so this is one of the way to qualify or to measure the optical transceiver performance. Okay, so besides TDECQ, there are also another up and coming method, which is known as the Eye MSA. Okay, so Eye MSA is up and coming, right? So besides TDECQ, okay, some customers are actually also looking at these standards. So the aim for the Eye MSA is, of course, to reduce the cost, to increase power consumption, and also latency as well. Okay. So because inside the PAM4 transceiver, we are using a DSP chip, right, to process the signal. So all this will actually increase the latency and also increase the power consumption as well. Yeah. So Eye MSA actually is looking at reducing orders to lower numbers. Okay. So for example, in terms of latency, in a standard optical transceiver, we're looking at maybe 100 nanosecond or more. But in the Eye MSA, we are targeting at below 20 nanoseconds. Okay, so this will help to improve in terms of latency in the optical transmission. And on the power consumption wise, yeah, we are also looking at reducing the power consumptions on the same type of optical transceivers. Right? Currently, there are about 37 companies is being involved in this new Eye standard, and of course, Anritsu is also one of the member in this Eye standards. And our sampling scope is also able to support this kind of Eye management as well, right? This is a GUI example of the measurement of the Eye standard right, on our sampling scope. Okay. The next, besides the pluggable optics, the optical transceivers that we known today, like the QSFP28, SFP Plus, or QSFP-DD for 400G, and so on, right? We are also looking at another form or another type of optics known as CPO, right? Co-package optics, where we integrate the DSP and also the POSA, ROSA, and the front end all into the co-package optics chip itself, all right, to become a one big module that integrated everything into one component. Of course, the aim or the motivation to develop this CPO is to reduce the power, right? As we know that data center actually use a lot of power. They are huge power consumptions in the data centers. So if the individual optical transceivers is able to reduce power, that is one of the big motivation, right, for to develop this type of CPO solutions. Yeah. And also, because of this CPO package, we are also able to increase density and also reduce costs, right? At the same time, support higher performance as well. So these are the key drivers today, where we are looking at this kind of CPO solutions compared to the current pluggable optic solutions. But of course, the current pluggable optics also has its advantage, right? For example, it's pretty flexible. You can swap very easily for different kind of transmission standards. You can swap between a DR4, LR4, FR4, and so on, right? You can freely plug and play and swap and so on. And multi-vendors, right? So you can swap between different vendors. You have no problem. Interoperable and intercompatible. Yeah. So these are the key benefits of the current pluggable optics. Yeah. So in future, the two different type of optics may be coexist. All right. Okay. So here is another deeper overview of various way of integrating the optics into the CPO. Right. So there are various ways. For example, using NPO method, near photonics optics, or even SR, which is very, very close, or also a direct CPO. But different technology has its different challenges, and also the testing need might be different as well. Okay, yeah. But the key things or the key goal that we are looking at is, of course, power saving and also scalability, right? To scale up to higher bit rate, and so on. Yeah. And testing of the core package optics is also another challenge, right? So after you build the CPO, how are we going to qualify or to test it? So in the industry now, we are still trying to figure out what is the best way, right, to test this kind of CPO core package optics. But basically, what we understand is that we need to do a few things. One of them is, of course, to test the bit error rate. So you will need a BERT to do that. When you want to look at optical eye, you'll need to have a sampling scope. When you look at the optical signal, you'll need to have OSA. And in the higher end testing, for example, higher layer testing, for example, you need to look at the Ethernet traffic stream and so on. You will need a traffic generator. Okay, so these are some common testing requirements that will be needed, right, on the CPO package. Yeah. Okay. So with that, let me launch the second poll, right, to the audience. I think poll is now on the screen. So what's the best describe your application on the optical transceivers? Okay, we'll have a 1-minute poll. So please help to participate. All right, and then we will see the poll result in a short while. I think maybe we will stop the poll in 10 seconds. Right, we stop and then let's see the poll result. Okay, so here is the poll result. As we can see, yeah, majority of the audience will be on the data centers. Okay, some of them are on core network. All right, thank you for the poll. And then we move on to the next topic. Okay, our testing solutions are available for testing the optical transceivers. All right. So next we talk a little bit more about the testing needs and the solutions that we have, right, on testing the optical transceivers. So here is one of the very typical setup on testing optical transceivers, right? Normally you will need a bird to generate the electrical signal, pattern generator to generate the traffic, and the error detector to measure the bit error rate. Okay, and on the optical side, you will need a sampling scope to look at eye diagram. And then in some cases, you will also need the OSA if you're looking at multi-wavelength transceivers, for example, LR4, ER4, or WDM transceivers. You need to look at wavelength and also the side-mode suppression ratio of the laser, and so on. Yeah, so for that, you will need OSA. And attenuators for you to check the receiver sensitivity of the receiver, right? So this is a very typical setup, right, when you want to evaluate optical transceivers. Yeah. On the other hand, if you're looking at multi-channels, right, nowadays some transceiver has multi-lane. For example, LR4 transceiver, you have 4 lane, right? You can also look at all the 4 lanes at one go. Right? In that case, you will need a multi-channel scope that is able to look at the 4 lanes at the same time, like the Anritsu BERTWave MP2110A, right? Allow you to have a 4 lane to evaluate all the 4 channel signals at the same time. Okay. And on the other hand, you might also need a recovery circuit, right, to trigger the scope. Okay. Yeah. And for the electrical signal side, usually nowadays, some of the transceivers, they have a built-in ASIC chip that able to generate the pattern and do the bit error rate measurement. Right? If not, then you might still need a pattern generator and the error detector to do the bit error rate test as well. Yeah. Oh. So third application example of that scenario is to testing some optical network or optical components. All right. Yeah. You can also use the wave or the sampling scope to do this kind of optical transceiver test as well. Yeah. So here, these are some few application example that popular or quite common when customer need to use the sampling scope, right, to do the test. Okay. This is our test solution, the Anritsu BERTWave MP2110A, right? It's multi-channel BERT and sampling scope in one chassis. Okay, it has a built-in PC, so you do not need to have an external PC to run the hardware. Right, internal PC is built in. All you need is just a monitor, maybe keyboard and a mouse. You're able to use it as a standalone product. If you want to use it on a remote environment, you don't even need to have the monitor, keyboard, and mouse. Okay. So on the front panel, you will have scope on the top, and on the bottom you can have a BERT configuration, or it can also be replaced with the OCRU as well. Okay, so this is very flexible for our customers. So customer can have a choice to have a scope only configuration, BERT only configuration, or they can have a two-in-one BERT and scope all in the same box. All right. And for the CRU configuration, we also have two different options available for the customers. we have the 53G baud OCRU available, and also the 26G baud OCRU available as well for the customer to choose, right? Depends on their applications. So for the 53G baud configuration, of course, for customers who are looking at 800G, 400G, 200G, and 100G config testing, they will go for the 53G baud. Then for customers are looking at 26G or 32G fiber channel and so on, or even 50G, and they may look at the 26G OCRU configurations, right? So it's flexible and customer can have either choice or can have both installed at the same time on the BERTWave. In terms of the scope configuration, there are also various options available, right? From 4-channel, dual channel, single channel, and also electrical inputs are available for our customers. Okay, so again, customer has a choice, right, to select either of the configuration available for their testing needs. Yeah. So when the customer have the scope and the BERT installed together in the same chassis, in the GUI itself, right, you will have two GUI side by side, running side by side. The BERT GUI and the scope GUI both can operate at the same time. That means you can use the BERT and you can also use the scope simultaneously, right? Two functions can operate at the same time. And if you're looking at just the scope only, we're able to display up to 4 channels simultaneously like this with 4 windows with high-speed sampling speed of up to 250 kilo samples per second. So this will allow you to collect up to 1 mega samples in just 5 seconds. This is one of the critical specification when we talk about manufacturing testing speed, right, in the manufacturing environment for the sampling scope. All right. So for the 4-channel application, right, some customer will use it to measure the 4 different component or 4 different waveform simultaneously like this, right? This will help you to reduce the test time by 75%. Instead of measuring channel by channel, one by one, you can measure 4 channels at one go, all right? Or in some cases, some customer measure 4 devices at one go, right? 4 DUT connect to one 4-channel scope that allow you to measure 4 devices simultaneously as well. Okay, yeah. So these are the key advantage for customers who is having the 4-channel scope configurations, right? And next, this is our PAM4 solutions, right? Besides NRZ, of course, the sampling scope is also able to measure the PAM4 signal, and very importantly, TDECQ measurement is available. And sampling speed remains the same as 250 kilo samples per second. All right. So we are supporting as high as up to 58G baud PAM4 measurements. Yeah. Practically, most customers are looking at 53.125 gig baud rate, right, which is where the 400G and 800G standards come about. Okay. So when we talk about PAM4 or TDECQ management, it's much more complicated compared to the NRZ management, which is quite straightforward, right? So for some customers, they might have some issues setting up the BERT or setting up the scope, right, to measure the PAM4 signal. So with that, we actually also has a unique tool for the customer. So this PAM4 TDECQ tool will help the customer to set up the parameters very easily by selecting the device that the customer is testing. So for example, the customer is testing a 400G QSFP DD-LR4 device. You can select the device from the drop-down menu, and a lot of setting parameter is already being preset or predefined in this tool. So it automatically preset what are the testing parameter that is needed to test this 400G device. Okay, so this will help the customers to actually reduce their test time, right? And also at the same time able to help them to test a higher bit rate transceiver as well. For example, not just 400G, but also 800G transceiver device. Because this TDECQ testing or TDECQ assistant software tool is able to support testing needs up to 800G and able to display up to 8 waveform in one display. Okay, so this is our current 800G testing solutions available on the MP2110A BERTWave. So for customers who are looking at testing at 400G today and upgrading to 800G in the future, yeah, the MP2110A is able to do that for you with upgrade path up to 800G in the future, right? Measuring 8 lanes or 8 waveform at one go using the TDECQ assistant software, right? Which looks like this. Okay. So besides the BERTWave or the scope, we also have the MP1900A, which also support up to 8 lanes of PAM4 with 100 gigabits per second. Okay, so this forms up the total solutions available for customers who need to test 800G transceivers. So we have the pattern generator and error detector, and also the scope looking at the eye diagram as well, right? Total solutions for the 800G transceivers. So besides the scope function, the MP2110A, of course, also have the BERT capability as well. So within the MP2110A, it has a 25G BERT and the optional 9.5 to 14.2G BERT as well is available for the customers to choose. And we support a single channel, dual channel, and also a 4-channel configuration, right, for the BERT configuration. So the BERT, of course, include pattern generator and also error detector as well. Yeah, with very good low intrinsic jitter of 600 femtosecond, which is very important for the pattern generator, and also high sensitivity on the error detector side, which down to 25 millivolt peak-to-peak typical. So here is the GUI on how it looks like on the multi-channel solutions. So for customer who has the multi-channel BERT, you're able to see all the 4 channel of the BERT in one screen like this. And of course, you can also split the screen into 2. All right, one side is the BERT, and then the other side is the sampling scope. All right. So with that, let me put on a third poll, right, to the audience to check about some of the common challenge, right, that you have, right, on the optical transceiver test. Yeah. So we have 1 minute poll, right? So we'll stop this poll in 1 minute's time. And, 10 seconds more. Let's take a look at the poll result now. And so we receive various response, right? Limited budget, and also challenge to minimize costs for buying. Yeah, these are some typical issues that everybody is facing. Okay, so but not to worry, you can always talk to our sales guys, and then we'll try to help you to resolve whatever issues that you have. Okay, so with that, let me conclude, right, our overall product portfolio. All right, so this is the last agenda that we have, right, the overall product portfolio, and then to follow by, we'll have a question and answer session before we end today's webinar. This is the overview of Anritsu product portfolio. So today we discuss about this MP2110A, which is targeted for manufacturing or mass production for optical transceivers and also for optical components. And we also briefly mentioned about MP1900A, which is our high-end BERT, which is able to generate up to 8 channels of PAM4 signal. Okay, so some customers also use it for R&D application, and also for high-speed serial bus application as well, right? Besides PAM4. Okay, so this is can also be used for testing the optical transceivers and optical component. And for the R&D portions, we also have things like the optical VNA, right? In the early stage where you need to qualify your optical component to measure your optical component. We also have the optical network analyzers available for our customers. Okay. And also OSA, optical spectrum analyzer, for you to look at the optical signal. For example, look at the power, the side mode suppression ratio, SMSR, and so on, for evaluating the lasers and WDM signals, of course, this. And for customers who are looking at the network layer, right, to check on the network transmission equipment, for example, we do have the MT1040A or the MT1000A, which is a traffic generator and also a bit error rate measurement device. Right, the MT1040A will support up to 400G dual port in a single chassis and up to 100G 4-port in a single chassis as well. Okay. The MT1000A will support 10G, 25G, and also 100G in a single chassis. So that depends on the customer's needs. So we have 2 different solutions available, right, for the customer to choose from. Okay, while they have the need for testing the network equipment. Yeah. So with that,